Hello dear friends, welcome to Byjus Exam Prep and I welcome all for this particular series which is Formula 1 series. The first of its kind, okay, and in this session we try to cover almost all formulas from Discrete Mathematics, my dear friends. Hope you are all ready for this particular Formula 1 series on Discrete Mathematics. All formulae in one shot by me. Hi sir, welcome to one and all. Yeah, please mark your presence. Dear friends, so discrete mathematics, all the important results which we need to know in the systematic order. So I will be presenting all the important. Hi, very good evening Akshita Sharma. Good evening Mukhopadhyay, Sagnika. And before starting, the person who is teaching you is Sridhar Dhulipala, myself Sridhar Dhulipala, having 20 plus years of teaching experience, and my qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. See, I am associated with BYJU'S Exam Prep from past 1.5 years, and under BYJU'S Exam Prep you can find this particular category called Learn with Video Lessons. From past 1.5 years we created this visualized animated content for you. It is first of its kind, recorded gate content. And with Byjus you are having dual advantage, that is both recorded, it's not just recorded sir, visualized animated content together with the valuable live sessions. Of course many more. Am I clear? Hi sir, good evening. Now, without wasting your time, shall I start with the Formula 1 series? You're all ready? You're all ready for this Formula 1 series? See, I'll be going in the systematic order, the order in which we should know the most important and the standard results. My dear friends, if you want to get this particular PDF will be available, but the PDF will be having a password. Those who attend this session completely can only able to access that particular PDF. So here we will be having multiple PDFs. It is not a single PDF sir, I will be sharing topic wise. The PDF will be shared to you topic wise in the Telegram group which is CS_Sridhar. This is my Telegram group. In that you will be getting the PDF but not completely. It is password protected, my dear friends. It is password protected. So the password will be revealed in this particular session. Password will be revealed in this particular session. So those who want this complete list of formulae, around 300 plus slides, 300 plus slides in next 1.5 hours to 2 hours I will be completing. Okay? All the important results in a systematic order I will be giving. If you have any beginning or starting doubts, you can ask me. If you are all comfortable, then I can start with my session, that is Formula 1 series. All formulas in one shot. All formulae in one shot. You are all ready, sir? You are all ready? Yes? First start with counting part 1. See, generally I start with the discrete mathematics with basic counting techniques because almost in all topics we require basic counting techniques, my dear friends. Okay, let it be set theory, let it be logic, relations, functions, graph theory, any place you will be using basic counting techniques. So generally I start the discrete mathematics with basic counting. That is, I divide counting into two parts. One is called basic counting, the other one is called advanced counting. See, generally in discrete mathematics you hear this particular term called combinatorics. Don't worry about it. Combinatorics means simply counting techniques. So let us start with the basic rule, sum rule. Hope you all know it. What is the sum rule? Suppose an event A can happen in m ways, another event B can happen in n ways, then A or B can happen in how many ways? A or B can happen in m plus n ways. See, generally everyone knows this rule, But actually, when you say sum rule, one important point to be noted here is these two events are disjoint events. These two events are disjoint events. Suppose I am selecting a book set. So I am selecting discrete mathematics books and algorithms books. Suppose I am having discrete mathematics books 3 and algorithm books say 4. Now I can ask you a question, how many ways you can select a book? It's a simple question, no? How many ways you can select a book? You can select any of the 3 discrete maths books or any of the 4 algorithm books. You can select one book in 3 plus 4, 7 ways. You can answer the question, sir, if you want. See, here it would be little interactive. Results, mainly result. We will not get into derivations and other stuff, sir. Systematic order, what are the results we should know in each topic. 7 ways, very good. 3 plus 4, 7 ways. Suppose there is a book which also deals with both algorithmic techniques as well as discrete mathematics. There is something common between these two. Can you have 7 ways? Can you have 7 ways? Can you have 7 ways always? Always you will have 7 ways? No. So that is the point to be noted. Sum rule is when you are having disjoint events. Am I clear? No. Very good. Very good. Yes, sir. Hello, good evening, sir. Sharon, very good, sir. No, sir. Very good. So 7 ways is when there are disjoint. So that is the first rule called sum rule or addition principle. Different names people use. The second one which you need to know is product rule. Same story here. Event A can happen in n ways. Event B can happen in n ways. Then A followed by B can happen in how many ways? A followed by B can happen in how many ways? If you know it, I think already answer is given. You can answer. A followed by B can happen in how many ways? I'll give you a simple example. There are 3 discrete mathematics books and 4 algorithm books. How can you select one discrete mathematics book and one algorithm book, my dear friends? How can you select one discrete mathematics followed by one algorithm books? One discrete mathematics and one algorithm book. Huh? 21. Why you are worried about rational numbers between 1 by 2 and 1 by 3? Right, sir. So it is, see, there are 3 choices for selecting discrete mathematics. For each of these 3 choices, there are 4 choices for selecting algorithm. That is 3 into 4, 12 ways, my dear friends. See, now I am starting with very small speed or very, very slow mode, but it will be going in a very, 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 very fast mode, my dear friend, because we need to cover lot many. As I told you, around 300 slides will be there. Around 300 slides will be there, my dear friends. Please note that. 300 slides. Okay? So 12 ways you can do it. And here the important thing is they are independent. The events are independent. This most of the people misses, and they are worried about number of rational numbers between 1 by 2 and 1 by 3. Okay? So independent means, suppose if I say that if you select Rosen book, then you cannot select Corman book. If I say that, suppose in that Rosen book is there, if you select Rosen book, then you cannot select Corman book. Then what happens? The event becomes dependent. The answer will not be 12, my dear friends. So whenever you say this simple product rule, the answer is 12, that is 3 into 4 or m into n when they are independent, my dear friends. So that is the first result, my dear friends. Of course, second result. Now one more important rule which we need to know is indirect counting. Indirectly counting this, my dear friends. Counting indirectly. Many times you get this particular one. You want to count at least 1. You want to count at least 1. At least 1 means 1 or more. Okay, or you may say at least k. You may say this like at least k. At least k means what, sir? At least k means greater than or equal to k. See, direct way you want to solve it, you can say k, k plus 1, k plus 2, like that you can do it. But indirectly, how can you do it, my dear friend? Indirectly, how can you do it? total minus at most 1 less than that, k minus 1. And this is one of the important formula. Yes, Akshita Sharma, you are correct, sir. You given answer for at least 1. I am saying it for at least k here. This is at least k, my dear friends. Total minus at most k minus 1. Am I clear? And as I said, the most important result which mostly asked is at least 1. At least 1 is total minus none. And this indirect counting plays very, very important role, my dear friends, in counting. We solve many problems with this indirect counting. Many problems we solve it using indirect counting. Okay, for example, number of positive integers less than or equal to 1000, or we can say instead of number of positive integers, let us make it 3-digit number. Number of 3-digit numbers, number of 3-digit numbers not containing or containing 1, let us make it. Containing 1. Number of 3-digit numbers containing 1. See, now the problem is containing 1 means whether it is containing 1 once, twice, thrice. So directly if you do it, you will be having so much problem. But if you solve the same problem indirectly, from total 3-digit number, you remove number of 3-digit numbers, not containing 1, you will get the answer within no time, my dear friends. Am I clear? Number of 3-digit numbers not containing 1. Is it clear? Hope you understand. So what will be that? Total, how many 3-digit numbers? How many 3-digit numbers are there total? Number of 3-digit numbers is 900. Now, not containing 1 means you are filling the 3 positions in which first position cannot be 0 and it is also not containing 1. So first position we have 8 choices and remaining positions we have 9 and 9 choices, my dear friends. So it is 8 into 9 into 9. Am I clear? Hope you understand? Yeah. See, this is not a, session where I'll be discussing about, your doubts, my dear friend. This is a session where I'll be discussing about the standard results and how to go with it. Am I clear? Those who are worried about nonsense can do that. All the best. Right? One-to-one correspondence. The next one is one-to-one correspondence. Right? Now look at this one-to-one correspondence method. See, sometimes you need to solve a problem which takes lifetime, but there will be an equivalent problem which can be solved within no time, but both have same solutions. Am I clear? So, a one-to-one correspondence method is used in many cases. For example, finding number of subsets of a set. For that, instead of finding number of subsets of a set, we can find number of binary strings of length n. We will get the same answer. For example, number of subsets of a set containing n elements. You can solve the same problem by solving an equivalent problem, that is number of binary strings of length n. Number of binary strings of length n, my dear friends. So that would be the answer. So here, finding number of binary strings of length n is very simple. Can you tell me how many binary strings of length n are there? How many binary strings of length n are there? Of course, we give this particular formula 2 power n. Very good, Akshita. So two ways, because each position can be filled in 2 ways. 0 or 1, 0 or 1, 0 or 1. So 2 power, how many times? N times. So what is the answer, sir? 2 power n. Super Mukhopadhyay, you people are rocking, sir. It's very simple. Discrete mathematics is the easiest subject in the world, but people mess up with this. All the formulas are very simple, straightforward, no difficulty, no twist, nothing. Little common sense is required. Senseless people can never understand this. Am I clear? Those who are having common sense, I am telling you, it is the easiest subject in the world. Anyone with any background, even with 7th class background, can understand this. Am I clear? But they should have a sense. Now, number of subsequences are there of a string of length n. See, I am having a string of length n, sir. How many subsequences are there? What is a subsequence, my dear friend? A subsequence is formed by deleting 0 or more symbols. It is obtained by deleting 0 or more symbols. That is, each symbol may be present or absent, present or absent, present or absent. So, number of subsequences of a string of length n. This is the string of length n. How many subsequences are there for a string of length n, my dear friends? How many subsequences are there? Very good, sir. I think Nishu Kumar want me to write distinct. Oh. Okay, Nishu. Thank you for your suggestion. Taken positively. Right, Nishu? Okay, na? Nishu, is that okay? We are not, okay, distinct subsequences we are taking. So what happened? Each symbol can be repeated, means each symbol is having two possibilities. In the subsequence it may be present or it may be absent. Present or absent. Present or absent. And that is 2 power. And this method which I am giving, it is a simple product rule, and in discrete mathematics you use this particular product rule for almost 15 different problems, my dear friends. Simple product rule we use almost for 15 different problems in discrete mathematics. Now look here. Number of substrings, or sometimes people also call them as subwords. Of course, again we have to be careful with Nishu Kumar, because Nishu Kumar is here. We have to mention distinct, otherwise he will not accept. Number of distinct substrings of length n. How many substrings or subwords of length n are there? Substring means here the symbols can be removed either from the beginning or from the end, nowhere else, or both. See, in subsequence you can remove symbol from anywhere, your wish. You throw it, it's done. But in substring you can remove symbols from the beginning or you can remove the symbols from the end. If you remove the symbols from the beginning, what is obtained called as what, sir? Suffix. Suppose if you remove the symbols from the end, we call it as prefix string, my dear friends. Very good, Nishu. You're rocking, sir. N into n plus 1 by 2. What is the answer? N into n plus 1 by 2. So the answer is n into n plus 1 by 2. See here, substrings of length 1 will be, substrings of length 1 will be n, substrings of length 2 will be n minus 1. Continuing this way, substrings of length n would be, that is, every string is substring of itself. That would be 1. And it is sum of first n natural numbers. If you do not know the formula for sum of first n natural numbers, don't worry, it is here. This is the formula for sum of first n natural numbers, my dear friends. And what is formula for sum of first n natural numbers? N into n plus 1 by 2. I am also having another beautiful formula which I will be using regularly in discrete mathematics, that is sum of squares of first n natural numbers. Sum of squares of first n natural numbers. Not only in discrete mathematics, even in algorithms we use these formulas many times, my dear friends. Okay, they will ask you what is the complexity. You may be getting something like n into n plus 1 by 2, and using order of growth notation you say that theta n square. By neglecting lower order terms and ignoring the coefficient of highest order term, you are going to get what is known as order of growth notation. Very good, Mukhopadhyaya, super sir, super. And sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. We also have formula for sum of cubes of first n natural numbers, that is n square into n plus 1 whole square by 4, or you can also say sigma n whole square also, because n into n plus 1 by 2 is sigma n whole square of it is sigma n cube. Am I clear? Actually, you know, mathematics people are very lazy people. They will be using this notation like sigma n for sum of first n natural numbers, sigma n square for sum of squares of first n natural numbers, sigma n cube they use it for sum of cubes of first n natural numbers, my friends. See, when you are learning mathematics, you should also know how to use this short notations. Am I clear? Sometimes this short notation, most of the people are worried about it, my dear friends. Instead of writing this big way, we simply write it as sigma n cube. This is expressed as sigma n cube, my dear friends. Please note that. Now this is called harmonic series, my dear friend. Harmonic series. 1 plus 1 by 2 plus and so on, 1 by n. Actually, we can approximate this with, you know, summation is approximated with integration. So we get 1 by x dx and limits are from 1 to n. 1 by x integral is log to the base e. X limits are from 1 to n, which is ln n. But base of logarithm does not matter, so it would be taken as log n, my dear friends. Approximately. It is not exact answer, approximate answer. See, generally for harmonic type of series, whenever you get it complexities, you simply write it as theta log n, my dear friends. Of course, I will be discussing these ideas quickly when I do algorithms revision also. I will be coming up with complete revision of algorithms topic also. Got it? Next comes arithmetic sequence. You all know it. So very basics. We call it as arithmetic progression or arithmetic sequence. A plus D, A plus 2D. See, every time you are adding common difference, where A is called first term and D is called the common difference. And what is the nth term? What is the nth term? You all know it. See, this would be very interactive session, sir. You have to answer. There are so many formulas. Knowing formulas is not a simple game, my dear friends. See, some people always say, like, you know, I'll go conceptually. See, in examination, you can't derive things conceptually, sir. You should know standard results. They must be on your fingertips. Am I clear? Now, some people ask me how to remember it. How to remember? Anyone having that doubt, please comment. I'll explain that. Right. A plus n minus 1 into d, correct, sir. Very good, Nishu. Very good, Akhil. Very good, Akshita and Mukhopadhyay. You people are rocking, sir. You will recollect most of the formula in this session, sir. Those who already know a little subject can review all the formulas in a systematic order in this session. It would be around 1.5 hour to 2 hour session. I don't know how much time I take it, but it would be very interesting. Now, sum of first n terms. Sum of first n terms of an arithmetic progression. What is sum of first n terms, sir? It is n by 2 into 2a plus n minus 1 into d. That can also be written as n by 2 plus a plus, this a plus n minus 1 into d is last term. A plus n minus 1 into d is last term and a is first term. So you can also write it as first term and last term. Some people also write it like, you know, n by 2 plus t1, first term, tn, last term. So that is about sum of first n terms of an arithmetic progression. And what about geometric sequence or geometric progression? Very good, Nishu. Super, sir. Super. You are doing very good. Answer. Okay? Super. Next one, geometric progression or geometric sequence. What about geometric sequence, sir? So, we are multiplying with a common ratio every times, my dear friends. AR square and so on. What is the nth term of a geometric progression? Quickly, common ratio is R. What is nth term of a geometric progression? You know, many people are also having trouble with this type of simple formula also. And for this, you can't derive this, no? Derivation is also very simple, sir. Every time R is added, R is multiplied. So, nth term will be A into R power. Nth term, sir. Akshita, nth term. A into R power n minus 1. Of course, Akshita is, okay, want to go for the next result, that is sum of first n terms, which is given by, actually it depends on the value of R. Common ratio के ऊपर depend होता है इसका value. अगर R 1 से ज़्यादा है, if R is greater than 1, then it is A into R power n minus 1 by R minus 1. If R is less than 1, then it is A into 1 minus R power n by 1 minus R. So that also will write. I generally ask this question. When R is equal to 1, what happens? When R is equal to 1, what happens? No one writes. When R is equal to 1, what happens? Please tell me. ये तो बहुत बढ़िया सवाल है ना. n नॉट n सर, n ये शून्य नहीं होता है. हाँ निशु मैं पढ़ाया था, but this is a different place where we are talking about different things. Okay, right. So what happens? It is, you know, a. Every time what happens? A is added to itself. R is 1 means next time 1 is multiplied. A only. A plus A plus A plus A. How many times? N times. You are going to get NA. Very good, Nishu. Very good. I think Nishu remember things. Very good. Nice. Nice to hear that, sir. Sorry, it is going back. Of course, R is equal to 1. Let us write down for you. N into E. And one important result which we should know is when the common ratio is lying between minus 1 to plus 1. See, mod R less than 1 means what, sir? What do you mean by mod R less than 1? Minus 1 less than R less than 1. Then sum to infinity terms of a geometric progression is a very wonderful formula which is A by 1 minus R. Yes sir, long back. So let us not get into other things. Let us talk about formulas. Okay. Now for example, okay. So if I am having like 1 by 2 square, 1 by 2 cube and so on, sum to infinite terms. Can anyone tell me the answer for this? Can anyone tell me the answer for this? Very good Nishu. Super. You are rocking. Tell me half plus half square plus half cube and so on. What is the sum to infinite terms of this series? Formula. How to remember? How to remember the formula? Like this. A is what? A is 1 by 2. Common ratio is 1 by 2. R value lying between minus 1 to plus 1. Yes, I can apply this formula. A by 1 minus R. A by 1 minus R. And wow, Dinesh Teja, Mukhopadhyay, Nishu, Akhil, you are rocking, sir. And that's it. That is how we practice formula. Practice this 1 by 3 square, 1 by 3 cube like that. 1 plus 1 by 5 plus 1 by 5 whole square plus 1 by 5 whole cube and so on. Am I clear? Take a starting term 5 plus 5 by 2 plus 5 by 2 square plus 5 by 3 cube, 2 cube plus 5 by 2 power 4. Practice with numbers. Always practice the formula with numbers. Okay. See now, suppose you are having difficulty with this particular formula. Write it on a sheet. Morning 3 doses, afternoon 2 doses and evening 3 doses before bed. You will remember by next day, my dear friends. If you don't remember by next day, increase the dosage. You need antibiotic. That's it. And with numbers you practice. Got it? Now we move on to the next topic, that is Pigeonhole principle. See, Pigeonhole principle is very simple, sir. Suppose there are 3 chairs and 4 people. चलेगा? सब लोग बैठना है. Everyone should sit. होगा? नहीं होगा. See, नहीं होगा बोल सकते हो, but I am saying that I am forcing everyone should sit. What happens? So first person sit here, second person sit here. They are decent people, sir. They don't want to, fight. They are sitting. But fourth person don't have any vacant position. So he'll jump on one foot. That is what exactly Pigeonhole principle says. When there is a congestion or when there is less number of people or less number of places and more people, congestion will be there. Congestion. One remaining is he will sit on someone. That's it. That is what Pigeonhole principle says. See, this is the Pigeonhole principle. If there are n pigeonholes, here there are chairs, my dear friends, and n plus 1 pigeons, then some pigeonhole should contain at least 2 people. Correct or not? Correct or not? See, it's like 3 pigeonholes and 4 pigeons. See, whatever. See, this situation which I given is called worst case situation. First pigeon, second pigeon, third pigeon. They are occupying these pigeonholes in a systematic order. But fourth one has to occupy a preoccupied pigeonhole. So definitely one pigeonhole should contain at least 2 pigeons. Can you tell me which pigeonhole? Can you tell me which pigeonhole? That is not job of mathematicians, that is a job of astrologers. So we don't tell that. Okay, that is not our job. We don't teach astrology, sir. We can only say that some pigeonhole should contain at least 2 pigeons. We don't know which pigeonhole. Some pigeonhole. That's it. Am I clear? So don't get into astrology. Sir, मुझे पता है. अगर आपको पता है तो आप astrologer हैं. So you have a different career opportunity. Go for it. Am I clear? Generalization. This pigeonhole principle actually can be generalized. See, I'll give you beautiful result here. N pigeonholes है and n plus 1 pigeons है तो then some pigeonhole should contain at least 2 pigeons. Actually, n plus 1 you said this n plus 1 is the minimum number. But you know, from n plus 1 से लेकर 2n तक, from n plus 1 to 2n, the same result is guaranteed, my dear friends. From n plus 1 to 2n, the same result is guaranteed. For example, if you are having 3 chairs and 4 people, some chair will contain at least 2 people. 5 people, some chair will contain at least 2 people. 6 people, some chair will contain at least 2 people. Only that is guaranteed. Only that is guaranteed. Up to 2n, same thing is guaranteed. But once you have 2n plus 1 pigeons, यानी अगर 7 people है तो देखो systematic situation I'll tell you. First person go on here, second person go on here, third person, fourth person, fifth person, sixth person को बेबे. But seventh person has to occupy a already occupied cell. Am I clear? So in this particular case you can guarantee 3. So that's what. If it is 2n plus 1, you can guarantee at least 3 pigeons. At least 3 pigeons in some pigeon. At least 3 pigeons in some pigeonhole, my dear friends. See, the logic is very simple. When n pigeonholes are there, n plus 1 to 2n plus 1, at least 2. 2n plus 1 to 3n. See, it will not be written in books. You need to understand. Where 2n plus 1 is the okay, 2n plus 1 is the minimum value which guarantees that result. Whereas, up to 3n, the guarantee is the same. That is at least 3. At least 3. Up to 3n. But अगर वो 3n plus 1 हो गया तो, if it is 3n plus 1, if it is 3n plus 1, then what happens, sir? You can guarantee at least 4 pigeons. So we can write the general formula, no? The beautiful, powerful general formula. Kn plus 1. When you are having Kn plus 1 pigeons, then some pigeonhole contain at least n को हटा दो k plus 1. And this is the more general result. It works for all the previous cases. By putting k is equal to 1, you get it here. K is equal to 2. This is for k is equal to 1. This is for k is equal to 2. This is for k is equal to 3. Correct or not? So if you know this, you know all the results. That is a more general result, sir. Generalization we done. Generalization we done. Got it? Got it, sir? But every time you don't have to calculate like, you know, n plus 1 to 2n, 2n plus 1 to 3n, 3n plus 1 to 4. You don't have to do this, sir. We have a beautiful result for this. Okay? We have a beautiful result for this. What is that? If n pigeonholes are occupied by k pigeons, n pigeonholes are occupied by k pigeons, then some pigeonhole contain at least how many pigeons, sir? Ceiling of k by n pigeons. Ceiling of k by n pigeons. You can directly say this, my dear friends. So let me give you one example for this. Suppose 21 students watching this class. We wish it increases, okay, multi-floor or exponential growth is there. Let us see. Okay, share this session. Suppose 21 students are watching this video. Now, at least how many are born on same day of a week? At least how many are born on same day of a week? Same day of week means not this week, sir. Same day of a week means same day. That is, they are born on same day. That is on Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday. That is it. Can anyone answer this? Can you answer this? 21 watching, then at least how many are born on same day of a week? Answer to karo. At least 3. So you don't have to do, simply do 21. How many pigeonholes? That is, how many days are there in a week? 7 days. 21 by 7, seal of it, which is 3. Which is 3. But instead of 21, if I say 22 students, if I say 22 students, if I say 22 students, क्या होगा? See, this is how we practice, sir. For this, you don't need any books or anything. You just need to know some pigeonholes, like, number of days in a week, number of months in a year, okay, number of letters to be distributed to some people. All this comes under this. What is this? 41, Babu. Very Dinesh Teja, what happened, sir? 22 by 7 only, na? 22 by 7 means what? 3 point something. Seal means 4. Yeah, 4, at least 4. Mukhopadhyay, done right. Akshita Sharma, super. Cool. Wonderful. Nice. Bomb blasting. So now, this formula is not given in books. Write down, take down. It helps you to solve many problems very quickly. This is how we should, understand the formulas and write the way we want it. This is how I write it. This is how I write and I remember the formula for you. N pigeonholes are occupied by kn plus 1 pigeons. Then some pigeonhole contain at least k plus 1 pigeons. This is the pigeonhole principle. Every book contains this. But minimum number of pigeonholes guarantee at least k plus 1. Suppose if I give at least number, minimum number of pigeons to guarantee at least k plus 1 pigeons in some pigeonhole will be equal to what? For example, what should be the minimum number of students in this class? What should be the minimum number of students in this class to guarantee at least 5 born on same month of a year? Answer. See, formula with the problems. This is how we should practice things, my dear friends. Formula with problems is how we should practice the formulae. Am I clear? Immediately when you see a formula, if you are not comfortable, you feel that it is a very strange formula, dangerous, bad formula, handle that with problems. Handle that with problems, numericals. That's why people say always, numericals. But first you should understand the formula. Very good. So here he said at least. See, this at least value is given, sir. That is k plus 1 is given 5. That is k is what? 4. Then what is the minimum number? The minimum number is k into n plus 1. K is 4. What is n, sir? What is n here? What is n here? N is number of months in a year. N is number of months in a year. That is 12. 40. No one given the correct answer. Babu. Formulas are useful. Use them properly. Most of the people feel that they know it. What happened, Dinesh? 12 is correct. Dinesh Teja. Very good, sir. Of course, there is small delay, my dear friends. I am expecting answers very quickly. Good. So 4 into 12 plus 1. Okay? Okay, let me clear this so that we will not have that particular problem. And this is the idea, my dear friends, in general. So k plus 1 is 5 means k value is 4, and that we use to solve the problem. Suppose you want to call it as k, because k plus 1 you take the value, again complete k and solving. Some people want, at least k is given. What is the minimum number? K minus 1 into n plus 1. Either this way you can remember or this way you can remember. And this is the most powerful formula, sir. Most powerful formula. Am I clear? Most powerful formula. So the answer for this problem you remember? Answer for this problem you remember? 49. Right? So formula 49 is the first password for your first part of this. Formula 49 is the password for the first part of the PDF, my dear friends. Formula 49, I just written, I not yet created. I am going to create with this formula only. So till this time even I don't know the password. So if you ask me again, I don't even remember. Even I have to go through this entire video to remember this password. Got it? So you will get PDF, but if you want to open that, you need to know the password. And the password is formula 49. Formula 49 is FORMULA 49. Formula 49. No. Don't write. Don't write. Okay. Now we'll go for some permutation combinations, sir. Permutations without repetition formula. Okay. NPR, number of R permutation of n objects. Okay. R permutation. See the difference between permutation and combination one should understand. Combination means what, sir? Combinations. Yes, everything it will contain. Everything it will contain. The PDF will be given to you. You can share it to it. Don't share the password. Those who want password, they have to hear my class. That is my condition. Am I clear? Clear or not? Right. R permutation of n objects without repetition. R permutation of n objects. Okay, I was talking about combination and permutation. No, combination means selection. Permutation means selection followed by arrangement. Selection followed by arrangement. And R permutation of n objects is given by the formula n factorial by n minus r factorial, my dear friends. Okay? Yeah, my Telegram link CS_Sridhar. CS_Sridhar. Yeah, that is my Telegram group link, my dear friends. Clear? Next one. So, number of linear permutations of n objects is given by formula n factorial. So, if you want to arrange n objects in a line, how many linear permutations are there? For example, if you are having n objects, how many ways you can arrange those n objects in a line? N factorial ways. Suppose if I say, I want to arrange n objects in a line in which two objects are always together. In which two objects are always together. What is the formula for that? Number of permutations of n objects in which two objects are always together. What is the formula for that? See, when you want two objects together, they are like one unit. 1, bandhu. 1 plus remaining n minus 1. Remaining is n minus 2. So, n minus 2 plus 1 is n minus 1. So, you have to arrange this n minus 1 objects. Okay, assuming AB as a single object. N minus 1 objects can be arranged in n minus 1 factorial ways. For each of these n minus 1 factorial ways, AB can be arranged among themselves in two ways. That is 2 factorial. So, the answer for this would be n minus 1 factorial into 2 factorial. This is a very interesting, important formula, my dear friends. Am I clear? Please remember. Okay, of course, you don't need this. You can continue. Now, what about number of circular permutations of n objects? What about number of circular permutations of n objects? See, for circular permutation, I'll give you a very important, what you call idea, because an idea can change your life. And what is the idea? Fix one object and arrange remaining linearly. You have to fix one object and arrange remaining objects linearly. This is the logic idea for circular permutations, my dear friends. For circular permutation, what is the idea, sir? Fix one object, arrange remaining objects linearly. So once you fix one object, that is fixed. See, it's actually called fixing one object is called as, fixing a point of view. Once you fix your point of view, it is linear arrangement only. So how many linear arrangements are there for n minus 1 objects? N minus 1 factor. Is it clear? This is very important. Now actually, here one point to be noted, sir. Here when you are talking about circular permutations, we are assuming that clockwise and anti-clockwise are different. Clockwise and anti-clockwise permutations are different. Suppose if clockwise and anti-clockwise are same, if clockwise and anti-clockwise are same, then number of circular permutations would be, in that particular case what happens, sir? It would be n minus 1 factorial by 2. The very famous problem which always people ask, like flower beads. N flower beads are there, how many ways you can arrange them in a, or how many ways you can make a garland. That very common problem which people ask, no? That one. And again, this formula is useful for us in graph theory. Hamiltonian cycles problem. I am going to use this formula there. Remember this. Am I clear? See, unless or otherwise it is mentioned, or it is understood from the problem, as I told you, garland problem with beads, or this Hamiltonian cycle problem, unless or otherwise it is explicitly mentioned, we assume that clockwise, anti-clockwise are different. So the answer would be n minus 1 factorial, my dear friends. The answer would be n minus 1 factorial, my dear friends. Is the idea clear? समझ में आ रहा है? Yes or no? Like, see, generally people feel formula reading. It's not that easy, my dear friend. Formula reading ये नहीं होता है. Formula जो है वो याद रखना है, याद करना है ना, ये बहुत important process है. And I always suggest students to do this process regularly. When you are traveling, when you are moving somewhere, think about direct formulae. At least, suppose you want to derive and think, no problem, do it. See, this formula practice which I tell students, I don't ask them to practice for 1 hour, 2 hours. I only ask students to spend 2 minutes, 5 minutes, 10 minutes. This is what I expect. When you are going for such competitive examination, spend 2, 5, 10 minutes of your time. You will get this time many times, while eating, while walking, while talking, while jumping. Any times you will get this 2 to 5 minutes time. There you need to recollect formulas, my dear friends. Am I clear? This helps you. This is a very important methodology, my dear friends. It is your journey with the results, formulae, standard procedures. You should think about, okay, if it given, how I should attack this particular problem. Like that, you should think about it. Okay? It's your travel, it's your journey, my dear friends. Okay, this one. Number of ways n people can be arranged in a row so that certain pair always together. Just now we solved this. It is 2 factorial into n minus 1 factorial. Certain pair never together. That is AB together. Just now I done know AB together. For that it is the formula. It is row. And AB never together. Certain pair never together means from total remove this. So you can take n minus 1 factorial common so that it becomes n minus 2. So some people want to remember this, my dear friend, as a formula. You can remember, no problem. Yeah, I am not. Right? Covering this. Number of ways n people can be arranged in a circle. Number of ways n people can be arranged in a circle, that we already know, it is n minus 1 factorial. But in which certain pair always together. When you want certain pair always together, the answer for this is given by 2 factorial into n minus 2 factorial. Because it is a circular permutation. And when you want certain pair never together, it should be n minus 1 factorial minus 2 factorial into n minus 2 factorial. Taking n minus 2 factorial common, it is n minus 1 minus 2. See my dear friends, in discrete mathematics, formulas also asked directly in gate examination. Directly the formulas are asked in gate examination. You can see previous gate papers, okay? You can easily identify all famous results were asked in gate examination directly. Not only in discrete mathematics, even in algorithm data structures also standard results were asked directly in gate examination, sir. They want you to know. Am I clear? For example, if you want to know the complexity of selection sort algorithm, they don't expect you to write the entire algorithm and derive. You should know which algorithms are having worst case time complexity this much, which algorithms are having worst case time complexity n log n. They want you to know standard fellows quickly. You can't say, sir, wait, I am recollecting selection sort conceptually. Then they say, come back next year. Okay? You are not allowed to do like that, my dear friends. Conceptually, you understand, fix and practice them regularly. Am I clear? They must be on your fingertips. Okay? Gate is all about, of course, conceptual, but conceptual base, you build your formula list and use them regularly. Remember them regularly. They must be on your fingertips. Okay? Like that. Now, combinations without repetitions. R combination of n objects. R combination of n objects. See, actually, when you do NPR, permutation means what? See, combination means selection. Okay. Permutation means selection followed by arrangement. Some people feel only arrangement, that is crime. Permutation means selection followed by arrangement. So when you want to do permutation, first you have to select. Then how many you selected are, those are you have to arrange. So what is NCR? NPR by R factorial. See, they are not, I don't think derivation, they are general common sense. See, in discrete mathematics, it's not like deriving the formula means 30 pages, 40 pages derivation or 2-3 pages derivation. So it's all common sense results. Most of them, except in graph theory or some results in relations, some results in logic, few. You can name those results on your fingertips, except for them, because their derivations may be little involved. For example, in graph theory, there may be some results which are based on, mathematical, induction, mathematical induction procedures. Otherwise, mostly the results are straightforward, sir. You can even understand by looking at the result. That is the beauty of discrete mathematics, right? So what is it? Come back to this. N factorial by R factorial into N minus R factorial. Super. Very good, sir. You people are recollecting formulas very quickly. Now I move on to the topic sets. There are more results in sets than basic counting techniques. But don't worry, they are very simple. But some of these results are also useful in logic. They are also same results in your Boolean algebra. Am I clear? Now, set. Suppose a set is having n elements. You all know power set. You all know what is power set? It is set of all subsets. What is it? It is set of all subsets of a set. Set of all subsets of A. For example, A is say 1, 2. What are the subsets, my dear friend? Empty set is a subset. Singleton 1 is a subset. Singleton set 2 is a subset. Again, the entire set is a subset. If you put all of them in a set, that becomes powerful set. Power set. That becomes power set. And if a set contains n element, this formula asked in gate many times, sir. You can easily see around 6 to 7 problems based on this in gate examination. Okay? People, underestimate results. Know the power of results. Know the power of results. Am I clear? We should know the power of result and we should know how to use them. Sometimes they'll make wonders, my dear friends. So if set A contain n elements, how many elements the power set contain? See here, what actually happens is, suppose A is there, no, 1, 2. What happens, this 1, 2 is there. Here I write subset. Here I write, what is the, how many elements are there in set A? 2 elements. I'll write binary strings of length 2. Now look here, empty set is a subset. Empty set is a subset. See, empty means one is absent, 2 is absent. So I'll give binary string like 0, 0. Now look here, I take 0, 1 binary string. Means 0 means the element is absent, 1 means the element is present. So which subset is it? It is 1. Now look here, I'll give you 2. Can you give binary string for this? Can you give binary string for this? Can you give binary string for this, sir? Please give me binary string for this. What is binary string for this? Quick, quick, quick. For 2, what is the binary string? One 0. And for 1, 2, the binary string is 1, 1. See here, what actually happened is, for every subset I can write a binary string, for every binary string I can write a subset. So what people understand is 1-to-1 correspondence. I already told you earlier. Very good, Ansari. Rocking Akhil, Teja, Super Sir. So what they done is, instead of doing this nonsense of writing subset, they just calculated number of binary strings. So if set A contains n elements, how many subsets are there? How many binary strings of length n are there? So we know number of binary strings of length n. And that is 2 power. That is 2 power n. Done. So that is the answer, my dear friends. Number of subsets of A. What is NDN? Okay, number of subsets of A. People feel I am asking same question. See, when I ask number of subsets of A, you can calculate number of 0 subsets or number of 0 element subsets. See, 0 element subset means from the set I need to select 0 elements. That is number of 0 combinations. Number of 1 element subsets, NC1. Number of 2 element subsets, NC2. Means I just need to select 2 elements. And so on, number of n element subsets. That is NCN. But you all know NC0 plus NC1 plus and so on, NCN is 2 power n. If you do not know it from today. This is another way of finding number of subsets of a set, my dear friend. This is another way of finding number of subsets of a set, my dear friends. Is the idea clear? Is the idea clear? Right. So they can ask you question, number of subsets containing odd number of elements. Yes. Number of subsets containing odd number of elements. Now you are looking for odd number of elements means subsets containing 1 element, subset containing 3 elements, subset containing 5 elements and so on. And that is given by the formula 2 power n minus 1. That is given by the formula 2 power n minus 1. And number of subsets containing even number of elements. Number of subsets containing even number of elements. 0 element subsets, 2 element subsets, 4 element subsets, blah 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 blah. And that is what, sir? 2 power n minus 1. Are you able to follow? Am I clear? Yes or no? That's it. This is a formula. Now about sets. Once you talk about sets, we should know complement. What is complement of a set, sir? The elements which are not belonging to set A. See, outside portion is complement. I quickly review all the important operations, right? Complement means the elements which are not in A, means outside A. Sorry to A. A intersection B, the common portion. Common portion is A intersection B. Means elements belonging to A and B. Union means what? Elements belonging to A or B or both. That is union, the entire story. And of course here we need to understand, sometimes what happens, you get this is A intersection B is empty. We call them as disjoint sets. What do you call such sets, sir? They are called disjoint sets ya to mutually exclusive sets. Mutually exclusive sets. Now comes the important identities. These 10 identities must be on your fingertips, sir. Whether you are doing Boolean algebra, that is digital, you are doing logic, you are doing set theory, 10 important properties. Later on I'll try to make analogy between set identities, equivalences of logic and Boolean algebra, 10 properties. Later on I do it. What are the properties? Idempotent, identity, domination, not dominos, domination, complementation, double negation. Yeah, you are going to get the PDF. There is a first PDF which is password protected, second PDF. So I'll be making like 2-3 subjects. See, presently I am taking 2, that is algorithms next week. This week I am taking discrete mathematics, that is today. Is the idea clear? The commutative, associative, absorption. See, this is very dangerous, sir. A absorbs A intersection B, that is khalega, eats A intersection B with respect to union, and A absorbs A union B with respect to intersection. Absorption is very interesting property, sir. Of course, the most famous properties are the De Morgan's and distributive properties. Is that clear? These are the 10 important properties we should know. See, association means we need to understand, sir. Association means here it is right to left association, here it is left to right association. Commutative means whether you do A union B or B union A. See, some people feel these are all silly properties. Obvious, no, why you are writing? My dear friend, not every operation satisfies this commutativity. For example, A minus B is not equal to B minus A. So we should always respect that particular property and the operation which satisfies that particular property, my dear friends. Next comes A minus B. A but not B. See, this part is missing, only this A portion. A and sorry to B. What is it? A and sorry to B. A minus B means what, sir? A and sorry to B. And nor are not associative. Yes, yes. There are so many fellows which are not that good, user friendly, bad people. Okay. So we should know that. So that's what I already written. So I clear this. So this portion. A but sorry to B. Now comes symmetric difference. See, if you see union, union is actually inclusive or either A or B or both. Whereas symmetric difference is exclusive or A or B but not. See, the common portion is missing. Common portion is missing, my dear friends. So A delta B means from A, it is like, this part is called A minus B and this part is called B minus A. Union of those two you can take it. Or from entire A union B, you subtract A intersection B. From entire A union B, you remove A intersection B, my dear friends. These are some interesting properties which I given. Please go through it. They are very powerful properties. You can derive them using this, my dear friends. Yes, yes, Nishu Kumar, I have given that also. A union B minus A intersection B also given that. I given that also, Nishu. Yes, sir. Very good, sir. Super, sir. Wonderful. And comes the inclusion-exclusion principle. Actually, the applications of inclusion-exclusion principle like Euler phi function, derangement problem, number of onto functions. There are many applications, sir. That means there are many results which are derived using inclusion-exclusion principle. Of course, we don't derive them, luckily. We only try to remember these formulae. But what we need to understand is all these formulas, if at all you want to see the derivation, they are all derived using inclusion-exclusion principle. I'll give you this idea for inclusion-exclusion principle for two sets, sir. Suppose you are having these two sets, A, B. See, A union B, if you want to know how many elements are there in A union B, first you said A, number of elements in A. See, when you calculate a number of elements in A, this common portion is counted. Then you counting number of elements in B, means this common portion is counted again. How many times this common portion should be counted, sir? How many times this common portion should be counted, sir? It should be counted once, but it is counted twice. So remove once. The common portion you have to remove once. Try करेंगे sir. Try करेंगे नहीं होता तो और एक extra session लेंगे. क्या होगा? हमें clear? Is there any rule like I have to? I'll try my best to complete it. If you are liking it, if you get it, if you get the information, okay? Right. So you remove that extra time like that. And this one, when you do this, actually, you need to understand this. These parts we need to understand, sir. This portion is called A and B. This portion is called A and sorry to B. This portion is called sorry to A and B. And this portion is called sorry to A and sorry to B, my dear friends. Hope you understand. Yes or no? Clear? Any doubts? Please ask me. Next one, we can generalize this for 3 sets also, sir. When you are having 3 sets, see there is a very interesting way of remembering this inclusion-exclusion principle, sir. 1 combinations are added, all 2 combinations with a minus sign, all 3 combinations with plus sign. And when you want neither A nor B nor C, this is called none. None means total minus at least 1. See, union means always at least 1, sir. Union means always at least 1, sir. So if you want none from total, you have to remove at least 1, my dear friends. Here also the story is same, sir. Here also same. None means total minus at least 1. And one important thing which we need to know is union problem means at least 1, my dear friend. Union problem means at least 1, my dear friend. Actually, if you want, you can generalize it for 4 sets also. You can generalize it for 4 sets, my dear friends. The idea for 4 sets is all 1 combinations with plus sign, all 2 combinations. How many 2 combinations will be there? 4C2. That is 6 2 combinations will be there. They all will have minus sign. Then 3 combinations will have plus sign. How many 3 combinations will be there? 4C3 3 combinations. Then 4 combinations will be 1, that is subtract. Exactly 1, okay. Exactly 1 means for 2 sets I am giving this fellow or this fellow. Exactly 1 is actually for 2 sets it is same as your symmetric difference, my dear friend. For 2 sets it is exactly same as your symmetric difference. A minus B plus B minus C. That is it. For 3 sets the story would be different. Exactly 1 means all this we need to add. All this we need to add. See, generally when you go for 3 sets, we try to fill this Venn diagram, sir. We try to fill this Venn diagram to answer the question. Is the idea clear? Hope you understand. See, if you are having any doubts, please ask me, my dear friends. Clear to you all? Next comes Euler 5 function. This is one of the application of inclusion-exclusion principle. This formula is derived using inclusion-exclusion principle. See, these are all direct questions, sir. You just understand now, you can go for and write examination. That is how we can remember this formula, sir. You just need to practice the formula, learn how to apply that. First of all, what is Euler 5 function, sir? Number of positive integers less than n. When you say phi n, what is it, sir? Number of positive integers less than n and relatively prime to n. For example, if I say 8, What are the positive integers less than 8 and relatively prime to 8? Relatively prime means what, sir? Their GCD must be equal to 1. So 1 is relatively prime to 8, 2 is not, 3 is relatively prime to 8, 4 is not, 5 is relatively prime to 8, 6 is not, 7 is relatively prime to 8. These are the positive integers which are less than 8 and relatively prime to 8. How many are there? How many are there? कितने हैं? 4 na? Euler 5 function tells you not what are they, how many are there, it will tell you. How many are there, it will tell you. It will tell you how many are there. It will tell you how many are there. Am I clear, sir? Am I clear? Clear or not? So it will tell you how many are there. Hope you understand. So for that the formula is this, my dear friend. For that the formula is this. Phi n is this one. See, what you need to do is here, simply what you need to do is, first you have to write the prime factorization. You all know what is prime factorization, my dear friend, for 8. What is prime factorization for 8? 8 can be written as 2 cube. 8 can be written as 2 cube. Correct? So here, distinct prime factor is 2. Then if you want to know phi 8, it is simply n. N is what? 8 only. 1 minus 1 by P1, because only one distinct prime factor. So it is 8 into 1 minus 2. 8 into 1 minus 1 by 2. That is 8 into 1 by 2, which is nothing but 4. Yes, Nishu, very good. Super, super. Others also can answer, my dear friend. It is not just for 1-2 members. Okay. We are seeing the formula and we are also solving the problems quickly. That is possible only in this subject, sir. You can quickly learn. Very, very good, Nishu. You are taking a lot of effort. Super. Now, for example, if I give 24, what is Euler 5 function phi 24? What is phi 24? Please tell me, sir. What is phi 24? Please tell me what is phi 24. So 24 prime factorization we have to do it. 24 is what, sir? 8 into 3. That is 2 cube into 3. So here the prime factors, distinct prime factors are 2 and 3. So then phi 24 is given by the formula 24 into 1 minus 1 by P1, 1 minus 1 by P2. Direct formula, you will get the answer, which is 24 into 1 by 2 and 2 by 3. So answer would be 8. Very good. I'll ask you one question. Shall I write it here? What is phi 7? Very, very good. What are you doing, Nishu? Please correct to me, Nishu Kumar. Quickly. Super. Why 6, sir? Phi 7 is 6. Very good. And what is the greatness of 7, my dear friends? What is the importance of 7 here? Very good, Ansari. Very good, sir. Akhil, very good. Nishu, very good. What is this 7? 7 is what? Why it is 6? 1 less than that. Because it is a prime number. So whenever you get a prime number, the Euler phi function value, that is phi prime number, is simply P minus 1, my dear friends. You can simply remember and use that to solve the problems. And the next one is nothing in its place. Derangement problem. What is it? Derangement problem. See, the idea here is, suppose I am having numbers 1 and 2. Malaikum assalam. Okay, 1, 2 is there, sir. 1, 2 is there. I want to arrange this 1, 2 in such a way that no fellow is in its correct position. Correct position means 1 correct position is first position, 2's correct position is second position. Now what is that I want, sir? No fellow should be in its correct position. No fellow must be in its correct position. So what is it? You can write it like 2, 1, my dear friends. But if I give you 3 numbers, how many derangements are possible, my dear friends? How many derangements are possible? How many derangements are possible? So you need to arrange the numbers in such a way that no number occupy its natural position. Of course, it's not necessarily numbers, sir. You have objects, you may be having people. You are arranging an objects in such a way that none of that object occupy its natural position is what is called as derangement, my dear friends. Derangement, my dear friends. Okay. So for 3 numbers it is 2. That is, can you give me that quickly? Can you give me that quickly? 3, 1, 2, 2, 3, 1. Only 2. And for 3 numbers, it is 3. For 4 numbers, what should be this? Number of derangements for 4 numbers, sir. Number of derangements for 4 numbers. What about this? Number of derangements for 4 numbers. Please answer this. So don't worry, we have the formula which is also derived using Inclusion-Exclusion Principle, and that is given by dn is equal to n factorial into 1 by 2 factorial minus 1 by 3 factorial and so on minus 1 power n by n factorial. And this can be approximated. Actually, this is similar to that of 1 minus 1 by 1 factorial plus 1 by 2 factorial and so on, which is nothing but e power minus 1 expansion, my dear friends. So it is approximately equal to n factorial into e power minus 1, that is nothing but n factorial by e, my dear friends. So that is exactly what our Dinesh Teja was saying, sir. Dinesh Teja was saying the same thing. So for D4, if you want approximate answer, you get it, that is 4 factorial by e you have to do it, which approximately some 8 point or whatever you get it, that is equal to 9, my dear friends. You take the nearest integer, my dear friends. You take the nearest integer, my dear friends. Is the idea clear? Yeah, you can do that method also. Exactly, you can do that method also. Okay, so that is exactly what we written here. So that is the formula for derangements, my dear friends. This is also derived using Inclusion-Exclusion Principle. Okay, let us start with logic. The formulae, okay, logic formulae. Let us see this. Proposition. What do you mean by propositions? Proposition is a declarative sentence. Declarative sentence means sentence which declares a fact. Declarative sentence which is either completely true or completely false. Let me write the completely. Declarative sentence which is either completely true or completely false. But not both. But not both is what is called as, proposition, my dear friends. Okay, see, propositions are the building blocks for the logic, my dear friends. See, the logic which we are going to discuss here is actually called as two-valued logic, binary logic only. We are not interested in fuzzy logic, my dear friends. We are talking about only binary logic. So, the logic provides rules. Logic provides rules which can validate the two-valued arguments. Okay, they can be two-valued mathematical argument, physical arguments, or anything, my dear friends. So they actually provide rules to verify the validity of arguments. And the advantage of these rules is, of course, they can verify the validity of arguments. They also be used in many places, my dear friends. Okay, for correctness of algorithms you can use it. Okay, for correctness of programs you can use it. Even in digital circuit design we can use it. That is the advantage of this logic, my dear friends. And for creating these rules we need to create a formal language. Okay, and for that, okay, the building blocks are propositions. See, in propositional logic, kaha hai? We'll do it it little later. We are talking about logic and why you are going for this. Relations topic we discussed that. Relations topic we discussed that. So in logic what we discuss is how to create the rules. How to create the rules. And for that first we start with propositions. First we start with proposition. We understand what are the propositions. Then we try to create connectives or logical operators. See, this is the algebra, propositional algebra. So whenever you want algebra means we need objects as well as operations. So we talk about, the story is all about operations and objects. Am I clear? Using this we are going to create rules, my dear friends, nothing more than that. Am I clear? So connectives. So the important or fundamental connectives are negation, conjunction, disjunction, implication, by implication. These are called the fundamental connectives or the standard connectives or the basic connectives, my dear friends. First result. Suppose there are n propositional variables, how many truth combinations are possible? Because a proposition can be either true or false, but cannot be both. So if you are having a single propositional variable, it can occupy one of the possible truth values. See, my dear friends, here I am talking about propositional variable. For example, if I say proposition like 2 plus 3 is equal to 7, it is a false statement. It is a proposition. Okay, it is a constant proposition. Am I clear? For example, if I say Hyderabad is a city, this is also a proposition which is true. Okay, so this is true, my dear friends. So this is also proposition. Now, here you know this is a proposition, you know its truth value. You know its truth value. But when you say propositional variable means it can take, see, just like if I say x is an integer, what do you mean by x is an integer, sir? What do you mean by x is an integer? It can be true or it can be false. Huh? What do you mean by x is an integer? It can take one of the integer values. Similarly, when I say p is a proposition, it can take one of the possible truth values, my dear friend. That is true, false. But if you are having two propositional variables, when you are having two propositional variables, p, q, see, p can take one of the two possible truth values, it can be true or false. Q can be taking one of the possible truth values, true or false. So 2 square, that is equal to 4. So there will be 4 possible truth combinations, my dear friends. There will be 4 possible truth combinations, my dear friends. Like and there is a very simple way of remembering that particular truth combinations. Let me give you that also. Okay, I don't need this. Okay, let me write this. So that P means true, false. When you are having two propositional variables, the 4 truth combinations you can remember like this. You start with the last variable true, false, and double the number of truths and double the number of false, 2 truths and 2 false, like that. And if you are having, okay, you are having n propositional variables, how many truth combinations are possible? For first propositional variable, 2 truth possibilities, second one 2 truth possibilities, continuing this way, nth one 2 truth possibilities, totally 2 power n. So when you are having n propositional variables, you have to subscribe to the channel, then you can like it. Are you asking how to dislike? Same methodology. Very good, 2 power n, my dear friends. Very good, very good. Right. Now the 5 connectives. There are 5 important connectives. How to remember them? Okay. See, negation means not P. So when P is true, it becomes false. Negation P becomes false. When P is false, negation P becomes true. Now the other connectives, let us see how to remember them. Negation simply definition is not. So negation P is true when P is false. Now how to remember conjunction, and connective. It is called conjunction ya to and connective, my dear friends. And this but term is used as expression. For example, if you are having a statement like, I like tea but not coffee, that but is used instead of and connective, my dear friends. Sometimes the but term may be used instead of and connective, my dear friends. That is because in English language one statement can be expressed in multiple ways, but we should not worry about the nuisance of English language. That's why what they do is they also mention while teaching this connectives, they also mention how to express a particular statement in symbolic form or symbolic form in statement, and we not worry about multiple ways of expressions. So that's why they fix expressions here. Am I clear? That you need to understand. So P and Q is true when both P and Q are true. See, this is the definition. See, for conjunction you just need to remember one line of truth table, my dear friends. It is true when both P and Q are true. That is the definition. See, generally people write the entire truth table. Arey, P and Q it is true, then only P and Q is true. Rest of the cases, what happens to it? Rest of the cases, what happens to it, sir? P and Q is true when both P and Q are true, no? In rest of the cases, what is the story? What is the fate of P and Q? Good evening, sir. False. Very good. Ansari, that is what I expect, sir. Very good evening, sir. Srilashmi, and very good evening, Nishukuma. Rest of the cases it is false. So, when you are learning definition, you just learn this case. Conjunction is true when? Conjunction is true when both variables are true. Disjunction is true. This is called disjunction or connective. Disjunction or connective. Or connective. Okay. So P or Q we try to remember when it is false. Disjunction, for disjunction we try to remember when it is false. This fellow is false only when both are false, and in the remaining cases it has to be true. We don't write that because true 3 cases, who will write that? We try to remember the cases which are less, that is false case. Very good Ansari, super. Now comes implication or conditional. Implication, very good Sam, how to read it, sir? Samitab. Okay, implication. Sammy, maybe. Tab, you are writing that. Right, implication or conditional. See, for implication, we try to remember the definition in a very beautiful manner. True cannot imply false. True can imply false? True can never imply false. That is how we remember. So, P implication is false when true implies false. That is, this is false when true implies false. And how you remember it, sir? Remember this way. True cannot imply false. True cannot imply false, my dear friends. And comes by conditional, by implication. What about by implication? If and only if. By implication or if and only if. P by conditional Q is true when P and Q are having same truth value. P and Q are having same truth value. Same truth value means both are true, both are false, also true. That is, biconditional is true कब बनेगा? When it will be true? It is true when both are true or both are false. Let us not get into philosophy. We are talking about discrete mathematics. Biconditional is equivalent to P implies Q and Q implies P, as our superhero Nishu Kumar mentions. And out of these 5 connectives, one connective which you should master if you want to crack GATE examination, or if you want to understand logic at least, is implication. So I'll just give you some interesting facts about implication. An implication, we read it as P implies Q. Here there are some terminologies we should know. P is called antecedent or premise or hypothesis, and Q is called consequent or conclusion. So this is a terminology which people use for implication, sir. When you have implication, P can be called antecedent, hypothesis or premise, and Q is called conclusion or consequence. हाँ वो सब पढ़ेंगे, वो सब बताऊंगा, सब एक ही शॉर्ट में सब पढ़ेंगे, पढ़ सकते हैं ना? हाँ वो सब दे दूंगा पूरा. What's up? Okay. Thank you, Sri Lakshmi. Very good. Now look here. What implication says is the following, and you have to use this idea properly, sir. Implication, I given the definition: true implies false is false. So what I do is first I'll write the complete truth table. True, 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 false, false, true, and false, false. Okay, now look here, this is an implication, and we know this is false here. In the rest of the cases it is true. Now the important observations, because this plays very important role when you talk about logical implications or when you talk about rules of inference. If you want to understand logical implication or you want to understand rules of inference, you should understand this implication properly. Those who don't, no problem, sir. Let us not get into arguments, okay? Everything is fine as long as we understand, okay? If you're not understanding, I stop using Hindi, as here it is mentioned as some English channel, okay? See, it's all about, we need to understand. Am I clear? Got it? Right. Now look here. See, if you observe here, whenever Q is false, whatever may be P, whether it is true or false, oh sorry, not this, just doing the wrong thing. Yeah, not this, because whenever Q is true, whenever Q is true, whatever may be this, you are going to get truth value for P implies Q as true. Anything implying true is true. Now, suppose P is false. False can imply anything, sir. False can imply anything. That is, false implying anything is true. So you see here, false implying anything is true. See, I not filled the blank here. It can be anything, sir. But what is important for us? When it will be false, true implies false, then it is false. See, this is what you mean by understanding implication. Those who say they understand implication, they should understand this. And this plays very, very important role in logic, my dear friends. Without understanding this, you cannot complete logic, my dear friends. This is the most powerful, important and useful connective. Of course, I think I can clear this. Now, in English language, an implication can be expressed in multiple ways, and that creates a lot of trouble for students. Because here we are not learning English language, we are using English as a meta language or helping language. We should understand that. Am I clear? Here, English language should not dominate logic, because we only use as a catalyst, helping fellow, meta language. So, we are not worried about nuisance of English language. That is clearly mentioned in almost all books where they clearly mention the story of logic. So, because you express the statements in English language, we require to express these statements, we require a language, and that language is English language. And the troubles or the nuisance of that particular language should not trouble our logic. That's why what they do is they fix how to express a particular connective also. Other connective there will not be any big trouble. For example, end connective sometimes they may use instead of end they use expression but. Am I clear? They may use but. But most of the other connectives are straightforward. But for implication in English language there are multiple expressions. So it should not trouble. That's why what they do is they'll give you the different possible ways of expressing implication. And these are the most standard and important ways of expressing implication. So this implication can be expressed like P implies Q, or it can be written as if P then Q, or it can be written as P only if Q, or it can be written as Q if P or Q when P, or it can be expressed like Q follows from P, or it can be expressed like Q unless P, negation P, my dear friends. P only if, yes. So how to practice this, I'll tell you. For example, I'll give you some statement, you have to give me the implication form for that. X only if Z. X only if Z. Is it X implies Z or Z implies X? Is it X implies Z or Z implies X? I'll just put it like this. X implies Z, Z implies X. Which one is correct? Arey yaar, Nishu, Babu, wait. So only if it is same as this direct answer only. So it is X implies Z, not this one. Very good, very good. That is what I expect. See, when you are hearing a faculty, you have to follow his methodology. See, this is very important, sir. Whether it is me or anyone. Suppose you like my class. Suppose you are hearing somewhere someone else same discrete mathematics class. You cannot expect the results in the same order I was giving you. It won't happen. If it happens, it is called copycat. Am I clear? It won't happen. It should not happen like that. Am I clear? It's not a tape recorder, no? So, you have to hear it. That is, it is called a presentation. Then take what all important ingredients or important points which you need to know. Then you write them in your own way. See, this is short notes prepared by me. It may work for you, may not work for you, but it is mostly standardized thing. It should generally work for most of the people, but as I told you now, how you want to make it is your own wish. But you have to hear in my own way, then you have to convert into your own way. Am I clear? Please follow. Please follow. So in between, sir, P implies Q is negation P or Q, law of implication, law of contrapositive, exportation law. Wait. Sabar karo. Like this, we need to practice. Now look here, sir. Please read this. X unless negation P. X unless negation P. X unless negation P. Is it P implies X or is it X implies P? Which one is correct? So, that's it. See, when it is P implies Q in this particular form, this is another way of expressing it, sir. Am I clear? Why, Akshita Sharma, where you gone, sir? You are answering the previous one. Nishu Kumar, P implies X is correct. So, practice this way. So, write this expression, convert that back to that one. See, look, now look here. Negation P unless Q. Negation P unless Q. Please write the symbolic form for this. Write the symbolic form for this. Negation P unless Q. No problem, sir. No problem, Ashita. It does not matter. No problem. It is all part and parcel of the game. No problem. कोई बात नहीं. Write the answer for this. See, क्या होगा? Whatever is here, negation of that fellow goes here, and whatever is here, that goes directly here. So this fellow's negation go here. That is negation Q, and this fellow as it is here. That is negation Q implies negation P. Super, very good. Understand. Great. That's. Am I clear? So this is how we should practice this, my dear friends. You practice. Now after practicing with the symbols, then you change this symbol to some statements. You change this symbol to some statement. Okay. I don't like tea unless you prepare it. I don't like tea. So for example, here I like tea is tea, sir. Tea is I like tea. You prepare tea. Prepare it means you prepare tea. Okay, so let us call it as prepare. P means prepare. You prepare tea. So now here, when you identify the propositions here, well, I don't like tea. I don't like tea means negation tea unless you prepare tea. You prepare tea means P. So what is it? Negation P implies negation. So first thing is you practice with this. See, you write this, convert that into implication form. Now you replace these fellows with some propositional statement. Anything you can write, sir. You can write some funny statement. I jump only if you cry. You can write that. So there is no restriction in this. You practice like. For this you don't have to see books and do some nonsense. These are all straightforward, common sense. Am I clear? I continue only if you respond. I continue only if you respond. Warning you. Thank you, Nishu. What about others? Say something. So, I continue only if you respond. I continue only if you respond. So, is it C implies R or R implies C? C implies R or R implies C? So, it is C implies R. Continue implies respond. Continue implies respond. Actually, in English language, you say this like, I continue only if you respond. It's like, warning actually. I continue only if you respond. It's like, I don't continue if you don't. See, if you don't respond, then I will not continue. That is what I am trying to say, sir. See that statement, I will continue only if you respond. In English language, in what sense it will be used, sir? If you don't respond, then I will not continue. That is exactly what it is. Okay, that's exactly what it means. See, if you don't respond, then I will not continue. Later on, we learn something called contrapositive, where this fellow is equal to C implies R. In that particular sense, this particular symbolic form is used, or this particular expression is used, my dear friends. Is the idea clear? So practice it like this. This looks very simple, sir, but these are all very important where people, mess up with this. Okay, I see people write some English nonsense, and some people, they start working on their grammar also, and some people join, spoken English courses for this. Don't do that. It's common sense. We require only English language as meta language, sir. Okay, so don't join spoken English classes, and don't show your English talent, how good you are in English and all. It's not about that. We just use English language. Okay, we don't symbolize English textbooks, English novels. No, please remember that. And one more important thing, this is very much used in, theorems. See, generally, you'll get theorems like this. P implies Q. Continuous implies differential, it's wrong. Differentiability implies continuity. Differentiability implies continuity. See here, if differentiability, that is P part, in this P part is called sufficient condition. So whenever the function is differentiable, 100% it has to be continuous. Differentiability becomes sufficient condition. Whereas Q part becomes necessary. So for differentiability, what is the minimal requirement? Continuity. So this part, Q part is necessary and P part becomes sufficient, my dear friends. So these are used actually in theorems, my dear friends. If you want to understand theorem statements, you should know these two expressions. See, they are not just given for fun or any other things, my dear friends. They are used for, writing statements into symbolic form. You are trying to symbolize the statements. Am I clear? See, in artificial intelligence, of course, the advanced version of this, the predicate versions are used. But this logic, if you understand, that can be generalized for predicate logic, my dear friends. Once you understand, knowledge representation of artificial intelligence, these ideas are used. The statements into symbolic forms are used there. Precedence of operators, sir. So this is the order of precedence, sir. Negation is having highest order precedence, whereas by implication is having lower order precedence. For example, if I give P implies Q or R, in this, R is having higher precedence than implication. So the meaning of this means, what does it mean, sir? This means it is equivalent to P implies Q or R. This means it is P implies Q or R. Am I clear? But if you want to get the meaning like P implies Q or R, the parenthesis is required here. Parenthesis required. Here the parenthesis required. Here parenthesis not required. If you don't write parenthesis also, if you want this meaning, you don't need to write parenthesis, my dear friends. But if you want to get this meaning, you have to use parenthesis. Am I clear? Parenthesis must be used. Yeah. Now a proposition which is always true. A proposition which is always true is tautology. See, a proposition which is always true for all the possible truth combination is what is called as tautology, and a proposition which is always false is what is called as contradiction. And sometimes tautology is also called valid, sometimes contradiction is also called absurdity, my dear friends. It is called absurdity. It is called absurdity. And a proposition which is true for at least one truth combination is satisfiable. Suppose it is true for, Babu Nishu, class up to 8:30. After that, I may come up with this session, one more session later on, sir. As it is continuing, I am just continuing. Next one, and a proposition which is true for at least one truth combination is satisfiable, and a proposition which is neither tautology nor contradiction is called contingency. Yeah. So now we understood the basic ideas. Now there are some equivalences. Actually, you've seen same equivalences, or actually call them as identities under sets. The first one is idempotent law. P or P is P, P and P is P. Identity. P or P is P, sorry, P or F. Identity means you should get back same P with respect to contradiction. Or, so for or, okay, or connective, we have to use F to get back same proposition. And P and T is equivalent to P. Domination. With respect to or connective, tautology dominates. With respect to and connective, contradiction dominates. Negation. P or negation P is the entire universe. P and negation P nothing common. And double negation. Negation of negation P is P. Commutative law P or Q is Q or P, and P and Q is Q and P. Associative law P or Q or R is equal to P or Q or R, and P and Q and R is equal to P and Q and R. Left and right associations are same for OR and AND connectives. For OR and AND connective, left and right associations are same. And absorption, see, with respect to OR connective, P absorbs P and Q, and with respect to AND connective, P absorbs P or Q. De Morgan's the most famous. See, mostly people practice these rules like this, but this is not the way to practice, sir. You have to practice them properly. For example, you know, this is also De Morgan's law. You can apply De Morgan's law. What is the answer for this? What is the answer for this? What is the answer for this? So here it is P applied. See what it says. When you have this, negation is applied and changes to R, negation is applied to this. So negation is applied, negation of negation, P is P, R connected, change it to AND connective, negation is applied to this. That is P and negation Q, my dear friends. P and negation Q. Am I clear? And you also see these results in reverse direction also. You also see these results in reverse direction. For example, negation P and Q is equivalent to what? See here, this way people happily do it, but in the reverse direction people never do it. Here I want to take negation common. I want to take out negation common. So this negation is going out, so P will remain. This negation is going common means negation Q remains and AND will change to R. So we should see the results in both the direction. Equivalences means two-sided conditions. Equivalences are two-sided conditions, my dear friends. Is the idea clear? Yes or no? Any doubts? Right. Now you see these operations or these properties are same for sets or logic for Boolean algebra, my dear friends. In sets, the objects are sets. In propositions, objects are propositions. In Boolean algebra, objects are Boolean variables, my dear friends. See, in sets, we have complement. Here we have negation, whereas in Boolean algebra, we have complement. Whereas in sets, you have union. In proposition, you have OR connective, whereas in Boolean algebra, you use plus, my dear friends. And in sets, you have intersection. In propositional algebra, we have conjunction, whereas in Boolean algebra, we have dot operation. And empty set we have under set, and here we have contradiction, whereas in Boolean algebra we have zero. Hello sir. In sets you have universal set, in propositions we have tautology, and Boolean algebra says mere paas ma hai, like mere paas one hai. So these are actually the first set of equivalences are equivalences involving AND, OR and negation. Now comes the second set of connectives, which involves equivalences involving implication. Equivalences involving implication. And here we have law of implication. P implies Q is negation P or Q. And law of contrapositive. See, this is very important, sir. And again, you should practice this as a rule. For example, only people practice this, but you should practice this in a different ways. You should be able to answer this question also. By law of implication, what is this equivalent to? By law of implication, what is negation P implies negation Q equivalent to? Now the second PDF, which involves set and logic. For that the password is true one. What is the password for that? True one. Don't write. The password for second PDF is true one. TRUE number 1. Very good. So what is it? See what is happening, P part is negated, so this part is negated, you get this. Implication changes to R, this part is as it is. So you get this part as it is. PR negation Q. Very, very good Ansari Sharma. Very good, sir. Beautiful. Nishu also. Sorry. And next comes law of contrapositive. Law of contrapositive says P implies Q is equivalent to negation Q implies negation P. And I request all the students not to share password to anyone. Not to share password to anyone. PDFs will be shared by tomorrow or tonight, because immediately I am having another session. So mostly by tomorrow I will share these 2 PDFs. Okay. And passwords don't share with anyone. Okay. They should get it from class. And if anyone asks, ask them to watch the class. So contrapositive rule. P implies Q is equivalent to negation Q implies negation P, my dear friends. Negation Q implies negation P. Exportation law. This is the next rule. This is very important rule, sir. P implies Q. See, actually, for every implication, there are associated implications called, for example, see, if this is implication, the converse of the implication is Q implies P. The inverse of the implication is negation P implies negation Q. And the contrapositive of an implication is negation Q implies negation P. Now, what it says, law of contrapositive, implication and contrapositive are one and the same. See, earlier I given one statement, you remember, P only if Q. Generally, this P only if Q, we use it in the sense like negation Q implies negation P. That is, if you don't respond, I will continue only if you respond. You remember, I given this example, I will continue only if you respond. So, the statement, when I say I continue only if you respond, what I mean, if you don't respond, then I will not continue. So, when I say P only if Q, we use it in the particular sense like negation Q implies negation P. But because of contrapositive, this is equal to P implies Q. Because of that, P only if Q is having the symbolic form P implies Q, my dear friends. P only if Q is having symbolic form P implies Q, my dear friends. See, they are very well formulated, my dear friends. The expressions which we consider also very well formulated. We should know that. Got it? And exportation law, P implies Q implies R is equivalent to P and Q implies R, my dear friends. Actually, I generally take this as problems only. I don't take this as a rule. For me, it is more like a problem actually. The exportation law is like a problem. P implies Q implies R if you are having. By using law of implication, I can write it as Q implies R by law of implication is negation QRR. P implies something can be written as negation PR, negation QRR. This can be written as negation PR, negation QRR. And here, by De Morgan's law, you can write it as negation of P and Q RR. And by law of implication, this can be written as P and Q implies R. See how simple it is, how logical it is. It goes, the logical problems always goes like this. You can just run, okay, like a machine. Am I clear? Because it follows the logical steps. Am I clear? So that is the beauty of this logical rules, my dear friends. There are some more rules for this equivalence to. Equivalence to is actually equivalences involving implications. Equivalences involving implication. Yeah. So these are the equivalences to only 4th rule and 5th rule. Actually here one rule I can take it like, you know, P implies Q, second one I am taking, and P implies R. So by law of implication it is negation PRQ and negation PRR. So this, what is common here, negation P is common, that is negation PR is common, Q and R, my dear friends, which is nothing but P implies Q and R. See, it's not like when it is AND is here, here also you are getting AND, that is P implies Q and R. Not Nishu, that is wrong. Babu Nishu, bomb blast, failed, wrong. P implies Q and R. So these are the next set of equivalences, sir. See here what we need to understand is if P is common, the left part is common, that is antecedent is same. For this rule, consequent whatever order, when you are having or you get or, when you are having and you get and. But when consequent is common and this is changing, this or changes to end, my dear friends. Or changes to end and end changes to or. And this plays very, very, very important role, okay, in logical expression, my dear friend. This plays very, very important role in logical expression, my dear friends. And next we have equivalence 3. These are actually equivalences involving biconditional, sir. These are the equivalences involving biconditional. See, biconditional we all know that is equal to P implies Q and Q implies P, sir. And biconditional means what, sir? See, biconditional actually says what, sir? Both must be true or both must be false. Both must be true or both must be false, and that is the rule, my dear friends. That is the rule for us. And biconditional, see, for implication is only equivalent to negation Q implies negation P. But for biconditional, see the beauty. P implies P if and only if Q is equivalent to Q if and only if P. It is also equivalent to negation P if and only if negation Q. All the forms are equivalent. So that is the beauty of this biconditional, my dear friends. And there is one more thing. I keep one negation and one variable. Then also we can write 4 different rules, my dear friends. So these are the very, very important rules for biconditional, my dear friends. And an implication which is tautology is called logical implication. And this is an example for this. P implies P or Q. Okay. So this is an example, because this is an implication which is tautology is called logical implication. See, most of the arguments which we do, see, generally what we do my dear friend, argument like, you say with your friend, you done this, you done this, you done this. Therefore, you are an idiot. So you make a conclusion based on the evidences. Correct or not? Based on some evidences, you say that he is an idiot. That's it. Conjunction of premises implies conclusion. So P1. See, even you see most of the movies, the court scene will come now. In the court scene, what happens? Judge will say, based on the evidences, based on these evidences, section this, section that, section this, conclusion. Judgment will be given. So that is general form of argument, my dear friends. And a general form of an argument is what is called as general form of an argument or inference. We also call it as an inference. And an inference which is tautology is called valid inference. If it is tautology, then you call it as valid inference, my dear friends. You call it as valid inference. Otherwise it is called invalid inference. Am I clear? Otherwise it is called invalid inference, my dear friends. Now, actually, any valid inference is called rule of inference, but if you list that, you have to maintain a very big book. What they done is they identified some very, very important rules of inference, and that is what earlier Nishu Kumar was trying to say, and they are called important rules of inference. So let me list out those important rules of inference. The first one is conjunction. P and Q implies P and Q. The second one, addition rule. P implies P or Q. See, later on I will be coming up with some, crash course kind of things, or, marathon series, where I will be discussing these problems, where I will take, these rules you have to keep it with you. Am I clear? I will be coming up with this both algorithms as well as discrete mathematics courses for you people in a very, very short span of time, how to complete that entire story. Here, practice series. And there I will be requiring the same formula list, maybe some additional nuts and bolts which are added there and there itself, so that we can continue happy. Am I clear? Will be announced soon. Simplification says P and Q can imply P, my dear friends. And the most important one is modus ponens or rule of detachment. Modus ponens is also called as rule of detachment. See, what this rule says is P implies Q, P is given, then I can conclude Q. From these two I can conclude Q. See, if you talk, then I stop. You talk. Then what I should do? I should stop the class. Correct or not? So that is modus ponens, my dear friend. Rule of detachment. Modus tollens says what, sir? P implies Q and negation Q. So here what happens? when Q is negated, the negation of P will be the answer, my dear friends. Actually, this follows from, P implies Q. So from this I can say negation Q implies negation P, which is contrapositive, and negation Q is given. So these two cancel by modus ponens, I get negation P answer. See, they are all proved like problems, my dear friends. They are all proved like problems, my dear friends. Hypothetical syllogism, transitive rule. P implies Q, Q implies R, then P implies R. If you walk, then, if you talk, then I walk. If I walk, you miss the class. So if you talk, you miss the class. So these are all simple silly examples you can take to remember these rules, my dear friends. Then comes disjunctive syllogism. PRQ, negation P, therefore Q. Either you talk or you sleep. You are not talking, therefore you are sleeping. Either you talk or you write. You are not talking, so you are writing. Examples. Then comes disjunctive elimination. See, this is very important. Disjunctive. P implies R, Q implies R. Okay? If I drink tea, I get energy. If I drink coffee, I get energy. Either I drink tea or coffee. So what is guaranteed? Energy is guaranteed. Conditional proof. P implies Q implies R. P and Q, therefore R. Actually, this P implies Q implies R, if you remember, the exportation law, it is actually P and Q implies R. So now we are given P and Q, these two cancel and you get R as the answer, my dear friends. And we have other rules like resolution. Okay, P or Q, negation P or R. See, these two cancels and you get Q or R as the answer. So that is the beauty of this resolution rule. Then comes constructive dilemma. Constructive dilemma. P implies Q, R implies S. P or R is happening, then Q or S can be guaranteed. Now this same thing, destructive dilemma, what it says, P implies Q, R implies S. Negation Q or negation S is happening, then negation P or negation R is guaranteed, my dear friends. So these are the propositional, my dear friend. Of course, I want to continue, but predicates, relations and graph theory, we'll try to come up with one more session, my dear friend, because it is taking much time. Yeah, too many results are there. So we'll try to see one hour, 1.5 hour session where we'll try to complete this formula, because discrete mathematics is all about formula results, my dear friends. So if you write so many, what happens? Obviously, it would be difficult. So I'll try to see. Obviously, you will attend those that particular session. If I come up with one more session, are you interested? Are you interested? Not tomorrow, sir. Tomorrow one more session already planned. So I'll announce that in my Telegram group. Please join my Telegram group for the notes, for the PDF. CS_Sridhar. This is the PDF. So surely I'll come up with this remaining predicate part and relations and graph theory parts. Of course, groups, other parts also. Surely. Yeah. So that's all for today. We'll meet next time. Will be announced on Telegram group, sir. Thank you. Thank you. Please share this session and don't share the passwords. Tomorrow I think C and data structures by Satya sir. Please do attend, okay, regularly to get that PDFs. Thank you.